Hi everyone, my name is Stuart. I'm going to be a moderator today for today's session. I have the pleasure of introducing Rene Spronk. He's a renowned trainer at FHIR that specializes in interoperability standards such as FHIR, HL7, V2, IG, and ICOM. With over 25 years of experience in HL7 and deep involvement in FHIR since its inception, Rene is dedicated to serving the implementer community and meeting their educational needs. As the originator of the acronym FHIR, Rene's creativity has ignited enthusiasm and success, notably in events like DevDays. Today, we have the privilege of hearing from Rene as he shares his introduction of FHIR from an HL7 V2 expert's perspective. So let's give a warm welcome to Rene.
All right. Well, thanks a lot. It's good to be amongst the HL7 version 2 crowd. And we were thinking of, okay, this introductory day where we explain FHIR mostly to people that are relatively new before we kick off the main conference tomorrow. And I thought, okay, it would be good to do a session to explain FHIR in terms of HL7 version 2. Because in a way, they're actually much closer than you would perhaps think, or as the FHIR crowd would believe you to think, right? So certainly, and I'm seeing all sorts of stuff I'm seeing not here, so I'm a bit puzzled. Okay. If we think of a version 2 message, okay, then a version 2 message, as you all know, is a sequence of segments. And this is exactly the idea that FHIR has embraced as well, reusability. The idea of the segment, which resurfaces in FHIR under the name of resources, plus resource relationships. Because if I were to redraw this model and go like, well, actually what we have is a model that shows us that we have a patient. And yes, because of the sequencing of the segments, we have our contact persons and the GP information, which again is related to that patient, and the encounter, etc., and our encounter data. So by the fact that in version 2, segments are positional, we have some implicit relationships between those segments. If we were to again redraw that diagram into this one, so now we're looking at a slightly different depiction, but again with the patient and the contact, etc., then this starts to look a bit like a data model. And that's exactly what we're doing in FHIR. We're again going for reusability, but now not for segments, we're now calling them resources, and for explicit references between those resources. So resources, if you know version 2 relatively well, then you go like, oh, resource, that's a reusability concept, much like a segment in version 2. And it is. In that sense, FHIR is a bit like version 2 plus, right? It has this reusability concept. Plus resource references. But those are explicit in our FHIR specification, whereas they are implicit, well, they're explicit by having a particular sequence of segments in a message. However, the scope of resources may very well be different than the scope of version 2 segments. So, for example, if we look at some of these segments, like a practitioner or a practitioner role, then that's a fairly good mapping. An analogy and tolerance in an AL1 segment, again, that's a fairly one-to-one mapping with the FHIR resource concept. But if you look at the practitioner, the attending practitioner, which is part of the PV1 segment, then that's kind of a separate resource in FHIR. So there is not really a one-to-one relationship. Conceptually, it's kind of a similar mechanism, but it's not, obviously not, exactly the same.
Remote side.
Okay. Well, actually, I'm actually already muted. This is not my mute you're seeing, that's the mute in the back of the room. Again, that's not my laptop you're seeing the laptop over there. So, okay, cool. Now, one of the major differences is the fact that FHIR has an 80-20 rule. That is to say, a phenomenon that we're well familiar with in HL7 version 2, that if you have a segment and it has 50 fields, pipe. But then in real life, if you're looking at that, it's mostly only the first 10 or 20 fields that have any values. So in FHIR, you more or less see the reflection of that in our resources, kind of the segments in FHIR, you're only going to include those data elements, those fields effectively, that are currently supported by 80% of systems out there. So that automatically means that you're not going to include absolutely everything in these resources. Which also means that should you need one of those values that are a bit more exceptional, not part of the common use cases, then you will need some sort of extension mechanism, like Z segments or Z fields, so to speak. The only problem with that is that most people think like, ooh, extensions and Z segments, totally unregulated, chaos, everybody does something. Well, that's certainly something that we recognize, so there is a mechanism to deal with that, but I'll get back to that. One other thing that's different in FHIR is that all these resources have a unique identity. And we're not used to that in the version 2 space. Yes, patients have a business identifier, but here I'm talking about the so-called logical identifier. That's effectively the, if you want, the primary key of this data item in the database. Whereas we also have a business identifier, and that's the identification that we're quite used to in the version 2 space. Patients have an identifier, could be citizen number, could be a tax number or something. We have healthcare provider identifiers. We have PV119, which is the encounter identifier. So we're quite used to dealing with these references in terms of encounters, in terms of business identifiers. Typical example, as you're probably familiar with here. Now in FHIR, all resources allow for business identifiers, but they must have, going back to my previous slide, this logical identifier. So all of them are addressed, identified via this more technical identifier. Which means if you're going to follow my session later this week about translation from version 2 to FHIR, that we have something that's mandated in FHIR and is not present in version 2. That's going to be interesting, as you can imagine. Now we have these references, and the references in FHIR are explicit. Actually, we have explicit identifiers in our version 2 segments as well. PID 25, for example, allows you to convey a business identifier for the mother of the patient, typically applicable when we're talking about newborn babies. But effectively, what we're doing here is sending the receiver some reference to somewhere else where they can get hold of the details of the patient that has that particular identifier. So this is in effect a reference in version 2. As is this one, the attending physician, we don't have all the details of the attending physician. We have the identifier of the attending physician, which potentially leads us to a table somewhere where we can get hold of additional information. So you see, this entire mechanism of having references is not new to FHIR, but certainly in FHIR it's much more pronounced, and in FHIR it's not based on these business identifiers, but it's based on logical identifiers, if you want the primary key of a resource in a database. And that's something we do not have in version 2. Now to show you, because I only spoke about all of this in version 2 terms, let's have a look at the FHIR specification and see how this actually looks in the FHIR spec. So we'll open up the FHIR specification, okay, at hl7.org/FHIR. And then on the front page, for those of you in the know about version 2, you will certainly recognize some of the chapters that we have in version 2, like administration, chapter 3 ADT, clinical and diagnostics, chapters 4 and 7. So it is kind of similarly structured as the other one, as version 2. Now, most importantly, and that's why the manual item is actually highlighted, is the set of resource types that exists. And the resources, because they are the key element towards reusability, play a key role, obviously, in exchanging data. Now, in recognition of the fact that a standard is working on all sorts of things at the same point in time, we see next to these names, we see a digit, and a digit is an expression of the maturity level. So not all of these resources are of the same maturity level. We don't have a similar concept in version 2. It would have actually made sense to have it. But now they're recognizing the fact that some of these are maturity level 0, which means absolutely alpha, can change anytime, can be dropped tomorrow, up to N, and N means that it's normative, which means it's stable. You cannot make any backwards incompatible changes to it anymore. Now, the example that we tend to use in such presentations is patient. Patient is one of the key resources, the equivalent of the PID segment. And obviously, if we start looking at the documentation, we have a tree-like definition that contains these 80% of common use cases, data elements that capture the data related to those. Now, resources may have, as I told you, references. And one of the key references that we, for example, have in this patient resource is a reference to the general practitioner. So we have a reference to, in this case, an organization resource, GP practice, or a practitioner resource. So this allows us to explicitly capture the reference between one resource and another resource. Note the equivalent in version 2 would be a PID segment followed by a role segment, where the role segment then contains the details of the GP. Now, just like in version 2, we have lots of examples in the specification. Because HL7, being an organization that's focused on implementers, is very much aware that implementers mainly look at examples. That's true in the version 2 spec, where we had examples at the end of each and every chapter, and it's certainly still true in FHIR. So we have a tab in the specification called examples that provides us with a whole host of example, in this case, patients. And I can just open one up in XML or JSON and have a look at the structure of it. And there we see the resource, the business identifier, the medical record number, in this case, for the patient. We see the name, obviously structured according to the data types as they exist in FHIR. But if you know version 2, you will certainly recognize a lot of the data type details. And we may also have these references. In this case, the only reference that we have in here is from the patient to the managing organization, the organization that manages basically this particular patient record. And this is an expression of a logical identifier, so it's primary key number 1, if you want, in the organization table. That's the thing that we are referencing. So it's a very explicit way, very technical way, if you want, of explicitly having these references. Let's go back to my presentation. Okay. One of the things where FHIR learned a lesson, not just from version 2, because FHIR is heavily influenced at the end of the day by version 2, But also a lesson learned from the CDA specification, the clinical document architecture, is that it's very good to have a human readable fallback mechanism. If the receiver doesn't understand the data that I'm sending them, because they don't know the structures, the structure definitions of the FHIR resource, then they can always look at the text. So the rule in FHIR says that each and every resource should have text. It is kind of as if it's mandatory in your version 2 message to, for each and every segment, have an NTE segment that contains the textual summary of that segment. Hey, if the receiver doesn't understand my fields and components, they can still show the text, and I will have interoperability between humans. And after all, that's what we're all about in healthcare. Another thing that you may be familiar with is the choice data type. If you know the details of the OBX segment, and in FHIR it looks like this, an X data type, if we are observing something, it could be a code, it could be an image, it could be all sorts of things. So when you create a model for an observation, you cannot state at that point in time what the data type is going to be. It's only at runtime, when you instantiate this model in JSON or XML, because those are the two syntaxes supported by FHIR, then you have to choose the appropriate data type. And the value becomes value quantity. So the X is replaced by the name of the data type that we are choosing. So value quantity, we go to the details of the quantity data type, 85 kilograms. Or if I want to observe a string, then here it says value string with the value patient loves to sing. Why you want to capture that is beyond me, but maybe they sing very falsely and you have to put them in a single room. I don't know. There could be all sorts of reasons for this. Okay, but the equivalent here would be this, where in OBX2 you use the data type string, how field number 5 should be interpreted. That's a special trick that we use in OBX. So in that sense, this is the exact equivalent thereof. We postpone the choice of the data type until we are having to serialize effectively our model. Now, when it comes to semantic interoperability, because that's what we want at the end of the day, we want to achieve understanding between senders and receivers. Likewise in version 2 as it is in FHIR. But in HL7 version 3 and in FHIR, we have a much more elaborate terminology model. Because if you want to achieve understanding, then it's not just about the syntax model, it's also about the codes that you're using. They carry quite a lot of meaning. So they have firmed up the whole terminology model in version 3 and in FHIR. And they came up with two concepts. They have a code system, which is a definition of codes. For example, SNOMED or LOINC or ICD-10. And that's kind of a dictionary. It defines the codes and what those mean. And they have defined a value set. And the value set is something that is a subset taken from the definitional code system. And this value set is relevant in a very specific context. Let's say in a data element somewhere, or in a particular item in your user interface. You don't need all of SNOMED, you need this part of SNOMED. So code system is a definition of terms. Value set is an enumeration of terms applicable in a particular context. Plus SNOMED, example here, childhood diseases from SNOMED, which is a subset from SNOMED, that will be a value set. Now, why am I pointing this out? Because in version 2, we actually have a much simpler model. So it's something to be aware of. In version 2, we have a data element, a field, or a component, and it's tied to a version 2 code table. Effectively, that's the equivalent of what we would call a value set in the FHIR space. And this value set is taken from this formal definition from the code system. In FHIR, all of this is now managed This is a FHIR resource and this is a FHIR resource. So we have much better management of value sets than we ever had in version 2. But a table is the equivalent of a value set in the FHIR space. Actually, in FHIR, we have 3 different data types to capture these concepts. We have code, coding, and codable concept. And a code is very simple. It's a bit like an HL7 table. Remember that tables in HL7 version 2 come in 2 flavors. We have HL7 tables and we have user tables. HL7 tables are defined by the HL7 organization itself. They're closed. You're not allowed to ever add anything to it. And you have user tables where you can do whatever you want. They're user defined. Okay. Now you more or less see the equivalent here. So the code data type is this thing that we know as HL7 tables. It's the closed table defined within the standard itself. And then we have this, which is the equivalent of the CE data type. Effectively, we have one code from one particular coding system or one particular table. And we have codable concept, which says, now we can have translations as well. Here you have the link code, and I give you this translation in SNOMED CT. Codable concept is, however, a data type that allows you to provide multiple translations. We have one original code, and then we can have dozens of translations thereof. Another thing that we tried in the HL7 version 2 space, I don't know if you've ever read that, this is chapter 2b in the specification, and that's about conformance. I want to specify exactly how this very flexible version 2 model shall be used in my particular context. And you have the capability to describe that in a computable fashion, express it as an XML file, okay, which was a very cool way of expressing it when they defined this conformance mechanism. And then you will be able to validate or do things like this. If you can express that I support this subset of version 2 and you support this subset of version 2, we can automatically calculate what the overlap is or where the differences are. Hey, cool. So I can see whether my interface is going to work or not before actually trying it. Very cool mechanism. And there was a central registry where you were allowed to upload, all vendors were encouraged to upload their conformance profile to a central registry so that you would have full public accessibility to whatever those vendors are doing. Great idea. I see some of you smiling who probably already know how this works in FHIR, because in FHIR this works very well. How many profiles are there in this version 2 registry? I think about 5. Okay, and they're test profiles. And this is probably because at the time, the culture of sharing such things openly simply didn't exist. We have much more open software, so this whole openness idea is much more relevant today than it was before. But hey, so we had the mechanism. You could, in the message header, just send a claim that as a message, I claim conformance to that particular conformance profile out there. And then the receiver could actually validate that. Now, the thing is, we see the equivalent of this directly in FHIR. FHIR also has such claims. I swear to follow a certain FHIR profile. And we have the tooling in place to create these FHIR profiles. But the underlying mechanism is obviously still pretty much the same. Now, I talked about extensions. If you have this rule that FHIR has, which version 2 doesn't have, this 80% rule, then you also have to have some governance around these extensions. You cannot willy-nilly allow for Z segments and Z fields because it will be one big chaos. Everybody already thinks that when I start talking about it, right? But it's not as bad as it seems, because you have the governance rule in FHIR that says, well, if you use an extension, you have to make the definition thereof publicly available in an international registry. So if you receive something and you don't know what it is in terms of an extension, you can just go to the registry and look up what the extension means, and hopefully that will help you to still interpret it. you have to realize that you have the choice. Either you model absolutely everything, then you get this humongous model that's useless for most people, or you go like, no, I'm going to restrict it somewhat, but then you need an extension mechanism. So it's part and parcel of the game. Security. In version 2, we didn't really do that much related to security. If you think of the most prevalent way of exchanging version 2, which is the MLLP protocol over TCP/IP, there is no security whatsoever. We have seen version 2 exchanges over SOAP and web services and other secure HTTPS, that sort of, but there is no real security guidance. So obviously FHIR is much better, a much more modern protocol. Version 2, basically silent on it. So again, these few subjects that I just covered, how do these look like in the spec? Let's have a look at that. Okay. So what I'm going to do is actually look at an implementation guide. And again, those can be found under the implementation guides link. And if I choose US core, which is the most commonly used US profile, then we have all sorts of profiles in here, these conformance profiles. And if you start looking at those, then these contain the constraints on, for example, an observation, okay, smoking status or something. And we see an expression of how that particular observation has been constrained. You can also look at examples here. Obviously, there are examples again. And we see bindings to value sets. For example, here we see that particular codes are fixed to particular terminologies. And again, that's something you can do at the conformance layer and use that in validation as well. But given the time, I will continue with my comparison. The key difference, if you start doing a comparison between the two, the key difference lies in the fact that one is a messaging exchange paradigm, whereas FHIR is mostly seen as a REST exchange paradigm. And that's a fundamental difference. So most of the difficulties, if you're trying to do mapping between the two, lie in that particular area. Because some of the other concepts like segments and resources, etc., are pretty well aligned. Data types are more or less the same. So it's pretty intuitive for people who know version 2 to move to FHIR. It's not that difficult. But to move from the messaging way of thinking to a RESTful way of data exchange, that's the fundamental difference here. That's where most of the problems lie if you try to do a side-by-side comparison. Because messaging is about, I'm sending you some stuff that's relevant now. Whereas REST tries to create a state of the world. A clinical data repository contains things that were and that are, right? In a message, you don't care about that. It's transient. It's whatever happens now. Patient is here, patient is there, right? So that's a fundamental different view of the world. And that's tricky to get your head around if you're new to FHIR. But as Graham Greaves says, shown on left in case you're in any doubt, as Graham Greaves says, well, yeah, there are obviously differences between these standards, but we're talking about the very same interoperability challenges and the very same interoperability space. But obviously, with FHIR, we have something in our toolkit that's much more up-to-date and modern than version 2 ever was. On the other hand, for my training courses, I asked Graham for a quote. So will FHIR replace HL7 version 2? And his succinct answer is, if it ain't broke, don't fix it. It's not going to happen anytime soon. However, that's what he also said. Here's the however, that as you see more regulatory requirements, as you have to capture provenance of where data came from, you will see slowly creeping some of the requirements into the version 2 space. And then you will find that version 2 doesn't cut it anymore, and you may have to switch. But it's not going to happen anytime soon. So for the version 2 experts amongst you, we will not be out of a job anytime soon. Right. I always love the statistics. If you put that to the FHIR crowd that's here and you go like, well, there's a heck of more data being exchanged using version 2 than using FHIR. That's a bit of a sobering thought. I'm not against FHIR, but we're going to end up with a mixture between a lot of standards. Hence, I will have a talk, and there will be other talks about, well, how do you deal with a mixed environment? Because it means you have to do mapping. And mapping is an interesting challenge. Again, mainly because messaging is just a fundamental different way of dealing with data than a RESTful exchange. That's a good time to give me a call. Because it's time.
Thank you, Rene. For the presentation.
So it's time for Q&A now. Are there any questions?
Why was there actually a reason to go to FHIR?
Why is there ever a reason to go to a new standard? I think if you're trying to do things that the older standards were never created, or they're not suitable for purpose. If you're trying to do things like create an open API on a data storage, and we all hate proprietary data silos nowadays. So there are a few changes that have going on the last probably 15 years. Think of vendor neutral archives. About that word, 15 years ago, they started doing that for images. Vendor neutral archive. Why don't we have that for all of our data? So if you start accepting that as a change, putting the patient into ever more control over their own data, and then you find out, oh, wait a second, but the older standards, they were never created for this environment. HL7 version 2, the precursor thereof, was created in 1979 to deal with interoperability within one single hospital, mostly administrative data. So at some point in time, you're going to hit the limits of what you can do with an older standard. There are new use cases, but the old use cases are still going to use, if it ain't broken, don't fix it, version 2. But there's a whole set of new use cases out there that are not solved by any of the older standards we have. That, to me, is the reason for creating a new standard, whilst incorporating the best things you have learned from older standards and trying to get rid of all the bad things you have done in older standards. Notably, in version 3, we have done a lot of good things, but also a lot of bad things, and we have learned our lesson, hence FHIR. But FHIR looks more like version 2 than some people would care to admit. I fully agree with you there. Tony?
I think the other reason is that someday I would like to not have 37 copies of the patient demographics on 37 separate systems. I would like to be able to say, what's Fred's address? And somebody somewhere knows it, and I don't have to spend millions of dollars a year transporting that data from A to B to C, and then trying to keep it in sync.
Yeah, but that doesn't go for FHIR. I agree with what you're saying.
Well, certainly the paradigm, and messaging is obviously a paradigm where you automatically duplicate data, which is difficult to keep in sync, whereas REST is in principle, but a lot of people deviate from this principle, is that leave data at the source and I'm going to fetch it when needed.